Okay, in this lecture we're going to cover the basics of complex numbers. Now you may remember that we've been talking about real numbers. Okay, that's integers, whole numbers and rational numbers and things like this. Well, of course, designating them real numbers begs the question, are there unreal numbers? Well, yes there are. They're what we call imaginary numbers. Now, why do we need imaginary numbers? Well, often when we come to an equation that says, well, let's find out what number, when I square it, gives me -1. Well, we know that a number squared means multiplied by itself. So if it's a positive number multiplied by itself, we get a positive number. When we have a negative number multiplied by itself, we still get a positive number. So how do we have this? Well, this becomes very useful when we start dealing in the area of electronics and other physical types of applications and computer science. And we call this an imaginary number. So what we do is we define I to be the square root of -1, because this is what this is really saying. It's find a number when multiplied by itself gives me -1. So in other words, I squared is equal to -1. Okay, this is what we call an imaginary number. Now, all real numbers, all right, can have an imaginary part associated with it. It's just that it's 0. And so any number that we write as a plus bi, where a and b are real numbers, is what we call a complex number. And you can see that all real numbers are complex numbers. All right, because we can write a number like 2 as equal to 2 plus 0i. Okay. All right, and so it just has, this is a real part and this is the imaginary part. Okay, so what we're going to deal with in this section is complex numbers. So these are numbers of the form a plus bi. All real numbers are complex numbers, and all imaginary numbers, all right, so all imaginary numbers are also complex numbers. Again, this is because we could write it as 0 plus bi. All right, so you notice that we have a 0 part for the real part. All right, so when we have a plus bi, this is the real part and this is the imaginary part. All right, now the first thing we have to work with is, what do we mean by equal or equality for complex numbers? Well, we have that a plus bi is equal to c plus di, two complex numbers, if and only if a is equal to c and b is equal to d. In other words, the real parts are equal and the imaginary parts are equal. Okay. Right, now our first thing is to deal with an expression of the form the square root of -a. So a is not necessarily 1 in this case. Well, this is simply the square root of -1 times a, which of course is the square root of -1 by the square root of a, which of course is I square root a. Okay, because the square root of -1 is I. Right, so let's do some practice on this. Right, first of all, let's suppose we want to simplify the following. All right, let's suppose I want to do square root of -64. Well, this would be the square root of -1 by 64, which would be the square root of -1 by the square root of 64, which of course is I times 8, and we usually write that as 8i. Okay. All right. what if we have the square root of negative 45? Well, this would be the square root of negative 1 times 9 fives are 45, so 9 times 5. So this would be the square root of negative 1, and I'm breaking this right down, square root of 9 by the square root of 5. So we end up with, this is 3 here, okay, always put that number first. Square root of negative 1 is I, and we can't simplify the square root of 5 any further, so that would be our result. Okay. All right, so that's the way we do that. I mean, we could have this as well. Okay, we could have the square root of negative 31. Well, the only way we can simplify this is this is negative 1 times 31, and this would be the square root of negative 1 by the square root of 31, which of course is I square root 31. We can't do anything with, and that would be the answer. All right, let's talk a little bit about operations on complex numbers. In particular, I'm talking about addition and subtraction. All right, now a couple of things to keep in mind here. We need to be careful of when we want to do something like the square root of negative 4 by the square root of say 25, negative 25. Right, now our normal radical rule said that this would be the square root of negative 4 by negative 25, which would be the square root of 100, which is 10. However, if you do it the separate way, this would be, okay, this would be 2i here, okay, square root of negative 1 by square root of 2, and this would be in fact 5i. So this was in fact 10i squared, I by I is I squared, but I squared is negative 1, so I get negative 10. Notice these are not equal. So we can't, when we're multiplying like this, alright, use the normal radical rules. So make sure you're careful on that. Okay, now let's do some examples of adding and subtracting. Alright, let's have a look here then of addition. Involves adding the real parts, so add or subtract. Okay, so let's do part A. So let's suppose we have 2 minus 3i, and we want to add 5, make it negative 5, plus 7i. Right, the key to this is always add the real parts. So I'd have 2 plus negative 5, and then we have plus negative 3 with this I, plus 7 I, and so this would be negative 3 plus 4i. Okay. Now with subtraction, the key is to change it to an addition. So let's suppose that we have negative 10 plus 5i, and we want to subtract 4 minus 2i. Okay, I always change it to an addition by simply distributing the negative sign into here. So I'd have 10 plus 5i. Okay, and plus, we're going to have negative 4 plus 2i. So this now becomes negative 10 plus negative 4. So 10. Alright, and then we have plus 5 plus 2i. So we end up with negative 14 plus 7i as being my result. So that's how we add and subtract, and we'll be going on now to look at some like this one and how we then multiply complex numbers.